Okay, so here is the solution to question number one of assignment one. First, we need to read the question. Draw a motion diagram for the following problem. Clearly label velocity and acceleration vectors. So we are only interested in velocity and acceleration vectors. Yeah. The question is not asking for displacement or position vectors. Yeah. Although you can imagine that a motion diagram can include position vectors or displacement vectors as well if you want, but this question is not concerned with those. So the object of study is the car, yeah, which starts from rest at a stop sign. So definitely you will have your frame 0 here, right? And I'm placing this dot here because for this problem we can easily go with a particle model. Yeah, there is no reason we should go for a complicated model. Particle model is good enough. Frame 0, I'm placing a dot there. Now, before I place frame 1, frame 2, frame 3, because I don't have any details, so let's read the question and see how it goes. It accelerates at 4 meter per square second for 6 seconds. And then it goes for 2 seconds, so there it's constant acceleration, and then it slows down at a rate of 2.5 meter per square second for the next stop sign. So it means that here here is the start, and it will ultimately stop somewhere. Yeah? That is what is mentioned here. So you can clearly see from the description that this motion can be divided into three parts. Yeah, speeding up, yeah, where it accelerates, then coasts, constant zero acceleration, and here it slows down, yeah, slowing down. So let's gather some information before we get into this. So it will be nice to have a table of times and actual velocities, right? And I will write speeds, yeah, because it's a motion in one direction. So listing speed is as informative as velocity because the direction doesn't change. And I don't want to write units here in these entries, so it will be nice to divide time by seconds so that I can only write the numbers. I don't need to write seconds each time. And same goes for velocity, speed rather. So rather than writing meter per second in every cell of this table, I will divide the speed by the unit, which is meter per second, and now I can easily write the numbers only. Yeah, so it simplifies my life. So yeah, it starts with 0. So let's assign 0 to the initial time. And then if you see the smallest time interval in this problem statement is 2 seconds. Yeah? 6 seconds and 2 seconds. And although this doesn't say much about the time, but we can easily say that, okay, 2 seconds is the smallest time we can pick from the data. I mean, we can go for 1 second as well, but that will make this diagram too complicated, and we don't need extra details. So let's include 2 seconds as well. So we would like to know what is the speed initially, and what is the speed after 2 seconds, and then what is the speed after 4 seconds. Yeah, 2 plus 2. Then after 6 seconds, so 4 plus 2, and then so on. Yeah, 8, 10, right? 12, and so on. Let's see how much do we need. So initially it's definitely 0. And remember, I'm just writing numbers because the units have been removed from these quantities. Now, what value should I write here? Yeah, I know the acceleration and it's a constant acceleration. So the time interval is 2 seconds. So I can simply multiply 4 by 2 and I'll get 8. So it means that after 2 seconds, the speed will be 8 meters per second. And yeah, after 4 seconds, because 2 more seconds have passed, so yeah, it will be another 8 units will be added to the speed. So now we will have 16. You can verify this, right? Another 2 seconds passed, so add that 8 another time, so you get 24, right? Um, yeah, and here that first stage where it is speeding up comes to an end, and the next stage is the coasting stage where the speed doesn't change. So for the next 2 seconds from here to here, the speed doesn't change, so it is 24, right? And then it starts decreasing, slows down, the speed starts decreasing. At which rate? 2.5. So because here the interval is still 2 seconds, so that 2 seconds will be multiplied with 2.5. So that is now the um, deceleration, and the change you get is actually 5. So now the speed has to decrease by 5 units. So this 24 will drop to 19. Yeah, you subtract 5 from 24 and you get 19, right? And what happens next? Because here again 2 more seconds, so this 5 was the change in 2 seconds. It will be subtracted again from that value, and that is actually now you get 14. So yeah, remember 24 minus 5 is 19. 19 minus 5, 14. Just like you do in that arithmetic sequence. Now what happens next? 2 more seconds, right? So this will decrease by 5 more units, and that will bring it to 9. 2 more seconds, 16, and then it will drop by 5 more units, so it will drop to 4. And here is something very interesting. Yeah, on one hand we would like to know how long does it take to get to 0, and maybe then you have to calculate that value, and if you try hard, maybe yeah, that value will come out to be 17.5. You can actually work that out, but I don't think we need that much detail for this question. We can safely assume that it will stop there and it will not move again for the next stop, because what this car does after the next stop sign is none of our business. Yeah, so life will be much easier if we assume that the next frame was taken again 2 seconds later. So rather than writing the actual value, we would like to write 18, so that you see we are now maintaining that interval of 2 seconds. So although the car stopped before 18, yeah, we can still write 0 because we can assume that it is not moving anymore, rather than writing negative values. And yeah, we don't want this car to go back to the initial station. So I think we are fine right here. Now, one misconception many students have is that because they have this calculation in their mind, so what they will do, they will just write draw these draw these vector arrows for the velocity. So let's say here I write v for the velocity vector, and okay, I say that okay, initially it is 0, so it will be of 0 length. Yeah, you know that convention, and then you will use the length 8. So but that is not a good idea. You know why? Because let me show you what the text says. Yeah, the text says clearly that the motion diagram, the velocity vectors in the motion diagram. Let me quickly find that point where he is giving the convention for the velocity vectors. Yeah, because motion is complicated, and see what these diagrams say. Yeah, these are actually average velocity vectors. Yeah, So the velocity vectors you indicate in a motion diagram, because you don't know what happens between one frame and the next frame. You cannot assume constant velocity every time, yeah, because you need justification for that. So constant velocity is not an assumption we can always make. So the safest thing to do is to choose a convention where you just indicate the average velocity between two frames. Yeah. Um, so that's exactly what we'll do right now. Okay. So frame 0 and frame 2. So from frame 0 to frame 2 in this interval, um, the initial velocity is 0, right? And the final velocity is 8. So what is the average of the two? The average is 4. Yeah? 0 plus 8 divided by 2. Similarly, the average in this interval from 2 to 4 is the average of 16 and 18, and that is, you can easily compute this to be 16 plus 8 is 24. 24 divided by 2 is 12. The average, so now I'm listing here, yeah, the next is kind of, I'm now listing the average speeds, right? The average between 16 and 24 is, I think this is 40 divided by 2, which is 20. And because the speed doesn't change here, so the average is the same as the actual value, which is 24. 24 plus 24 divided by 2. And remember this initial plus final, remember this initial speed plus final speed divided by 2 is something we can do only because the acceleration is constant. Yeah, and here the acceleration is 0. 0 is also constant. So when the acceleration is constant, whether it's 0 or not, you can safely use this formula. You must remember that you cannot use this formula if the acceleration is not constant. Yeah, but that is something you will see later in chapters to follow. Let's compute the average for the next interval, yeah, from 8 to 10. So it is the average of 24 and 19. A quick and dirty estimate will be to replace this 19 with 20, and 20 plus 24 is 44. 44 divided by 2 is 22, but because this is 19 and not 20, um, we can replace this with 21.5, right? 21.5. Um, I think writing 21.5 is not a good idea anyway, because the significant figures, if you look at this question, the maximum number of significant figures is 2. Yeah. So this calculation is not helping us in any way. So there is no reason, there is no point in trying to be more accurate than than we are justified. So I'll just write 22. Yeah, that's the safe bet. So the average is 22, going for significant figures. Similarly, the average between these two, 19 plus 14. So if you replace this 19 with 20 for simplification, it will be 20 plus 14, which is 34, and 34 divided by 2 is 17, right? 17. Um, yeah, I mean the actual value will be 16.5, right? Because this is not 19, this is 20. Sorry, this is not 20 but 19. So I can now replace this 16 with 17 with 16.5, and rounding to the nearest even will be 16, right? So rather than 17, I'll go. So you see, in both cases, we rounded it to an even number. That is something which you can remember. Similarly, for the average between 14 and 19, it is actually 14. So you can replace this 9 with 10 for simplicity. 14 plus 10 is 24, right? And 24 divided by 2 is 12. Yeah, so it is 12 again. Um, yeah, then 9 plus 4. So the average between 9 and 4. Again, replace this 9 with 10, and 10 plus 4, 14. 14 divided by 2 is 7. But because this is not 10, this is 9, right? So that will be, yeah, here you can actually go with 6.5, right? With 6.5. Because 6.5 has only two significant figures. That is justified, I guess. 9 plus 4 is 13. 13 divided by 2 is 6.5. Yeah, that's good enough. And 4 plus 0 divided by 2 is 2. Yeah, so now we have all the average speeds here. Yeah, so just to recap, we use the information given in the question or in the statement to list down the speeds at different time instances, but we cannot use actual speeds um, to draw our motion diagram, those in particular the velocity vectors. We converted um, those speeds to average speeds for each interval. Yeah, so for the interval between frame 0 and frame 2, we will use this average. For the interval from frame 2 to frame 4, we will use this average, and so on. These are the average speeds which will be used to draw the motion diagram. Of course, we're not drawing numbers, we will be drawing arrows, but these they will give us actually um, an indication of how long the arrows should be. So, I mean, if I start with this small arrow, and this dot is frame 1, so now remember, I'm using 1 for frame 1. Frame 1 will be here, right? This will be frame 1, this will be frame 0, this will be frame 2, this will be frame 3, frame 4, number, frame 5. I can remove the unnecessary details. Um, frame 6, frame 7, frame 8, frame 9. Remember, these values were time values, they were not frame numbers. So if I use this vector for the velocity, for the average velocity between frame 0 and frame 1, yeah, of length 4, the next has to be 12, and 12 is 3 times 4, right? So the next one has to be 3 times larger, yeah? So if this is 4, this will be 1, 2, 3 times 4. So here I can now place my frame number 2, a larger velocity vector, because it is now speeding up. The next one is 20. 20 is actually 5 times 4, right? So I will use that same unit, 4, 4, 4, 4, 4, yeah? 1, 2, 3, 4, 5. So this is of my next frame to make it 20. Yeah, this is a rough sketch, but you know what I'm doing, right? Similarly, the next one is 24. It's even longer. So 1, 2, 3, 4, 5, 6. 6 times 4 is 24, right? Our basic unit is 4. So this is frame 4. Yeah. The next one is 22. So a little shorter. Yeah, because now it's now speed is slowing down. So 1, 2, 3, 4, 5, 6 is for 24, and we need 22, so a little shorter. This is our frame 5, right? The next one is 16. Okay, 4, 8, 12, 16. Yeah, 1, 2, 3, 4 times 4 is 16. So this is our frame 6. You can realize now, you can notice that the velocity vectors are getting smaller and smaller. The next one is 6.5. 6.5 is almost half of 12, so I can just go with 4, 8, and somewhere shorter. I mean, if I'm not precise, forgive me for that, because this is not a precise diagram. We just need to be approximately accurate. And the next one is, um, I think I made a mistake. Yeah, let's see. So this is 4, then this is 12, right? This is 12, this is 20, this is 24, this is 22, this is 16. After 16, I have 12, okay? So this was a mistake. After 16, I have to go 12. 1, 2, 3, 4. This is 16. And for 12, I have to go 1, 2, 3. 3 times 4. Yeah, 12. So this will be my frame 7, and it is now 12 units. And the next one will be 6.5, which is almost half of 12. So it is 1, 2, 3 for 12. Oh, sorry, okay, 1 is for 4, 2 is for 8, so 6.5 will be somewhere here. So this is my frame 8, yeah, and frame 9 is just 2 units. So yeah, it's this is 4, so I will just go with frame 9, and that will be really, really, really small. Yeah, so I'm done now, right? Total five frames were needed. So I would highly recommend that you watch this video, and pause, and maybe you have to go back and forth and try to understand the reasoning. Yeah, it is very tempting to make trivial mistakes, um, and to skip some important details, but I think if you watch this video a few times, you will get into that mode of drawing your motion diagram accurately. But we are not done yet. Yeah, these are only velocity vectors. We now need to indicate acceleration vectors. So for that, I would like to use a different color, right? Let me use a different color. It's very easy, because we know that initially there was acceleration speeding up, then the acceleration was 0. So if you see, there was no acceleration between frame 3 and frame 4, right? So as we reach frame 3, before that, you can write just one symbol A, and throughout this, you can use a vector of some length for acceleration. And remember, that length is 4. Yeah. So if I say, okay, if I break it down into 2, so 2 for half, and this 4. This is our acceleration vector. I can just draw it somewhere in the middle. And then in this region, actually it is 0. So I can say 0. I can draw a vector of 0 length, right? I can just say 0, but it's actually, no, I don't need to draw any arrow. It is just this dot. Remember, I'll just write 0 on it to make sure that we are speaking of 0 acceleration. 0 acceleration, right? And then after the 4th frame, you have this slowing down. So from 4 to 9, anywhere you can just draw. I mean, you can either draw one arrow or multiple arrows, right? You can draw these arrows, um, and these arrows, remember, they have to be short to indicate 2.5. 2.5 is almost half of 4, so this arrow has to be shorter than that. Yeah, 2.5, a little longer. Yeah, and here, if you can even have more arrows here if you want. You can have more arrows here, provided they are longer enough. So one longer arrow here and one longer arrow here, but I think that one arrow is enough because we have little space here. So you just have one arrow here. Remember the length of this arrow and the length of these arrows, they must respect these values, yeah, because 4.0 and 2.5, if you compare the two, it is nearly double of that. So this arrow should be double in size of that arrow approximately. I think that was all for question number one, and we'll now move on to question number two, right? So in question number two, um, the diagram is given, although you are required to redraw the diagram, but I don't need to, because this is a solution. Yeah, I'm not a student solving this, so I can use the same diagram as if I have redrawn it. So let's get to part one of the question, and it says label the motion diagram with frame numbers. So I can now label it. So this will be frame 0, this will be frame 1 because this is the start, right? Frame 2, frame 3, frame 4, frame 5, and this is the same point, so this will also be frame 5. Remember, this is only to make it possible to draw the second part. So this is the same point. You cannot label it as frame 6 because otherwise you have no justification to ignore this comment. Same point. The next will be 6, 7, 8, 9, and 10, right? 10 is our last frame. So that was pretty easy. The next question or the next part is identify frame numbers for which the object is speeding up. So remember, here all the velocity vectors are pointing downwards, yeah, and the accelerations are also pointing downward. So I can say that, okay, for this frame 0, frame 1, frame 2, frame 3, yeah, even in frame 0 it's accelerating, yeah, because the acceleration starts right from the beginning. 4, in 5 it is not accelerating, right? Because in frame 5 it is now reversing, right? So 0, 1, 2, 3, 4, this will be the answer to part 2. Now the answer to part 3 will be identify frame numbers in which the object is slowing down. So right, the object starts slowing down right from frame 5. So 5, 6, 7, 8, 9, 10, all the way. So the answer to this part will be 5, 6, 7, 8, 9, right? 9. We don't need to write 10 because at 10 it has stopped, yeah? And when something stops, it cannot slow down more than that, right? So we are skipping 10 from here. 0 cannot be excluded because the acceleration started at 0. If it did not start at 0, then you cannot actually reach frame 1 with a larger velocity. But in frame 9, we can say it is slowing down. But when it reaches frame 10, in frame 10, it cannot slow down further. It has already stopped. Yeah. So you cannot have negative speed, right? So we are excluding frame 10 from the answer to part 3. That was it. I think question 2 was much simpler than question 1. So best of luck for this course, and yeah, expect quiz number 1 sometimes next week. It will be announced shortly. Thank you.